Okay, in this video we are going to convert from polar coordinate to rectangular coordinate and vice versa, rectangular coordinate to polar coordinate. In the video polar coordinate systems, I introduced the understanding of polar coordinates. Now in this video we are going to do conversion, because between two graphing coordinates of two different systems there has to be connection, so we can convert the object or addresses for objects in one or another coordinate into the opposite coordinate. All right, so but before, I would like to show you that unlike while in rectangular coordinate every object has unique address, which is x and y, in the polar coordinate system, a single point object can have more than one addresses. Okay, so let me show you that. Partially you are, I guess you are familiar, whoever learned Precalculus, so you are familiar with this. But I'm going to remind you. Let me choose this color. Let's start with this one. All right, assuming we have (45 degrees, we have coordinate for point P with the length, distance 2, and coordinate pi over 4. This is our pi over 4, and this is our 2, distance 2, and that is our distance. Okay, now what is interesting, that terminal side, based on the same terminal side, there can be generated several different angles. Let's go over these angles. Let's see which type of angles can be generated. So I'm starting with this one. Oops. Okay, I need two more angles. Okay, and one more. All right, so we have the same point P. Okay, distance is 2. All right, now let's say angle goes this way, starting from 0, making full circle, and coming this way. This piece I would do with green color, because this is our 45 degrees, right? Pi over 4. And the blue color is all our 360 degrees, yes? So we are doing 360 plus 45 degrees, right? And we are getting, let me see, this 45, it's kind of, let me make nicer 45, and we are getting 405 degrees. Well, let's convert into radians, which means we are doing 405 times pi and dividing by same 180. I practically didn't disbalance anything, right? Pi is on the top, 180 at the bottom, so multiply and divide by the same value. So, and we are getting, let me see, and we are getting the following picture. So I can reduce by 45. Here's gonna be 9. Here is gonna be 4. And we are getting here 9 pi over 4. So this angle is 9 pi over 4, which means coordinate is gonna be 2 and 9 pi over 4. Okay, next one. Let's work on next one, see what other angles can generate the same side. It's gonna be, if I take from here and go clockwise, which is gonna generate negative number, negative angle, correct? So what do we have? We have here, we know that this is our 45 degrees, right? Pi over 4. If I continue this by dashes all the way till 0, I will generate 360, right? Let me see, put point here. Pi, I mean P, it's 2, and let's figure out the angle. So it's gonna be 360 if I roll all the way, but negative 360 degrees, and plus pi over 4, okay? Because pi over 4 is going counterclockwise and 360 goes clockwise. And that's going to be equal negative 360 degrees plus 45 degrees, and we're going to get 315 degrees. Okay, let's convert into radians. Hold on, this is... Okay, green, also green, this is also green, and this one is we're going to put this color. Okay. So 315, negative actually, negative 315 times pi divided by 180 degrees, right? Where pi and 180 it's with one color because we just embodied this pi and 180. Now let's see how much we're gonna get. We can reduce by 45 degrees. This is gonna be 7. And this is going to be 4, and result is going to be negative 7 pi over 4, which means this is going to be negative 7 pi over 4, negative 7 pi over 4. That's going to be next coordinate for the point P. And lastly, let's see, our side is going this way. Okay, let me provide here arrow. So we are going to have our negative 2. So this is point pi, P. And let's see what angle it's gonna generate. I can go from here, from 0, come all the way to here, right? So what is gonna be, this is we are going to have here 45 degrees, pi over 4 this piece, right? Green one. This is going to be pi over 4. All right. And the rest is going to be 180 degrees. Okay. Let me move this a little bit further because it's getting crowded. Okay, we have it. So, what kind of angle do we get? We get 180 degrees plus 45 degrees, right? And we get 225 degrees. We convert to radians. 225 times pi divided by 180, and we are getting, divide by 45, it's going to be 5 times, divided by 45, it's going to be 4 times, and we get 5 pi over 4. So this entire angle is going to be 5 pi over 4. And finally, the point is going to be -2, the address of point, -2, and 5 pi over 4. Now, let's do practicing problems converting from polar coordinate to rectangular. Okay. Polar to rectangular. Okay, so we are given 6 and pi over 6. Okay, the formulas here we are going to use is going to be the following. X is equal r cosine theta, and y is equal r sine theta. So this is our r. R is equal 6, and theta is equal pi over 2. Pi over 6, I'm sorry. Okay, so let's find out x and y. So x is equal 6 times cosine pi over 6. Okay, which is equal 6 times cosine pi over 6 is square root 3 over 2. Okay, cancelling 1 and 3. And the answer get 3 square root 3. Okay, just on the side for drafting, cosine pi over 6 is square root 3 over 2. Okay, next, y is equal 6 times sine pi over 6, where sine pi over 6 is equal 1/2. So we have 6 times 1/2, and it's equal 3. Yes? 1 and 3, we are getting 3. So practically we converted 6 and pi over 6 in the polar coordinate. We converted into rectangular coordinate, which is 3 square root 3, comma 3. Okay, next one. We have rectangular and we convert to polar. rectangular to polar. So we have 0, free, where x is equal 0, y is equal 3. So let me draw it. Okay. Zero, free. Free is gonna be on my y, because this is y, right? 0, free. At the same time, this is gonna be our r, yes? The distance from beginning to the point. This is our r, which means we can say our r is equal 3, right? And angle automatically, because this is 90 degrees, pi over 2. So theta is going to be pi over 2. And the result is going to be, so we converted rectangular coordinate 0, free, converted to polar coordinate, which is going to be 3, and pi over 2. The other way we can generate, if I continue, if my, since r is an absolute value, so distance can be also negative, correct? If I provide negative sign, this is gonna be my negative 3, right? Y is negative. And the angle is going to be negative pi over 2, right? This way. Okay. And we can look also in a case. Let me color this one so you would see it's a different case here. We have their positive, this is P. Here we have negative, right? Okay, negative 3, comma, negative pi over 2. Okay. And lastly, we can have also positive 3, let's say, and the point is equal 3. And what kind of angle we can have? We can have such angle. Full circle and come back. There we go. So this is going to be 360 degrees, right? And plus 90. And this is going to be 450 degrees, which if you convert it, it's going to get 5 pi over 2. Okay, and this is equal 5 pi over 2. All right, so let me generalize this type of cases. So we have 4 cases like that. Okay, first one. Second one. Third one. fourth one. Okay, so when we have our point of x located somewhere here, point of x, and this distance is a, okay, which is going to be our r, correct? Distance a is going to be our r in the polar system, right? Then if our coordinates x, y, it's going to be equal a, because r will be equal a, right? Let me write down. It's going to be a and 0, because angle here is 0, right? Okay, so that is for polar system. Okay, next, my point is located here. Okay, this is my y, and this is our a distance from the beginning to the point. It's a, and it's the same thing, it's as an r. Okay, so our xy, that is equal 0 and a, then what we will have, our r and theta is going to be equal, r is going to be a, and theta is going to be what? Pi over 2, right? I forgot to put here, write down polar one, r and theta here. It's going to be equal, distance is going to be a, r is going to be equal a, and angle is going to be 0, right? Okay, next. Our point is on negative side. All right. Our point is here, which is going to be negative a. It's going to be negative number here, but the distance is going to be a, right? Because it's a distance, right? So this way we have xy is equal negative a and 0, correct? Okay, and r and theta is equal, it's going to be a, since we don't know a what value it's going to have, so it's going to be a, and pi will be our angle. Okay, and lastly we have xy equal 0, negative a. Okay, let me rewrite nicely. Okay, which is going to be on negative y, right? This is going to be my point here, correct? Which is going to be our y. And distance is going to be a, right? Okay, so, and what we are going to get, it's going to be angle, it's going to come like this. okay, which is going to be 360 minus 90 degrees, which is 3 pi over 2, 270 degrees. So this is going to match r theta is equal a and 3 pi over 2. Okie dokie. So on this video we looked into coordinates that are locating on one of the axes, either x or y axis. And in part 2 of this video I will explore conversion from rectangular to polar and vice versa, where when point is located in the quadrant, meaning there is no zero coordinates, there is n coordinate x and coordinate y. Okie dokie, see you in next video.